Here notice number 4. This is 8.4. Properties of rhombuses, rectangles, and squares. Page 30 through 32. Okay. So, okay, here it is. Properties of rhombuses, rectangles, and squares. So on this one, this is rhombus corollary. Corollary means it's true off of examples. So it says a quadrilateral is a rhombus if and only if it has 4 congruent sides. So you can see in the picture that AB, all these sides are congruent. So it says ABCD is a rhombus if AB is congruent to BC, if BC is congruent to CD, and CD if it's congruent to AD. So all sides are congruent. On the second corollary, it's for rectangles. It says a quadrilateral is a rectangle if and only if it has 4 right angles, and that's indicated in the picture here with the 4 right angles. And remember the IFF stands for if and only if. So this is what classifies a parallelogram as a rectangle if the angles are all right angles. So it still has the characteristic of parallelogram. Okay, and then the third corollary says a square corollary is a quadrilateral is a square if and only if it is both a rhombus and a rectangle. So realize the rhombus states that all the sides are congruent, and the rectangle specifies that all the angles are right angles. So a square is both a rhombus and a rectangle. For our first example, which I accidentally started writing, that's why there's white out there, it says for any rhombus RSTV, decide where the statement is always or is it sometimes true. Draw a sketch and example. So here I've drawn an example of what a rhombus, the properties of a rhombus, which are that opposite sides are parallel, opposite angles are congruent, and then for the rhombus all the sides are congruent. So there's my drawing that matches this picture. And the first part says that S is congruent to V. Is that always or sometimes congruent? And this is for any rhombus that we have. Well, S and V are opposite angles. So this is going to be an always true, because this is actually a property of parallelograms. Okay. And a parallelogram, I believe, was Theorem 8.3. If I page back just a little bit, nope, not 8.3. It was actually 8.4. Says that if the parallelogram, if the opposite angles are congruent, and that is what is being specified here. And this is proven by 8.4 because all rhombuses are definitely parallelograms. This is always a true state. On part B, it says, okay, well, what about T and V being congruent? Well, in my picture I have right here, it's obvious that T and V are not congruent, but there is one situation where T and V would be congruent. So this is definitely going to be a sometimes. This is a sometimes true, and the only time that this would be true is in one situation, and that is if for T and V to be congruent is if this is a square or rectangle where the angles have to be 90 degrees. And I'll put only if it is a square on this aspect. It has to be a square for this to be the case. Otherwise, it's not going to happen. Oops. Okay. Example 2, they give us a picture and they say, we want you to classify the shape and explain how you know this. Well, if I'm looking at it, I see that my sides are all congruent. And let me go ahead and put letters on here. Let's say A, B, C, and D. So let's see. On this, it says that all sides are congruent. So from that aspect, I can say that this is definitely a rhombus. And it could also be a square, because on the square, all sides were congruent. So there is a possibility of that case. So I know for sure it's a rhombus. But if I look at angle B up here at the top, I see that it is 127 degrees. Well, that means the opposite is 127 degrees. And to find angle A or C, I'm going to do 180 minus 127. And that tells me it's 53. That's what the other angles happen to be, is 53 degrees. Knowing that information, that tells me that A and B are not congruent. Therefore, this cannot be a square. B, C, and D have to be right angles, which means they have to be congruent. So if I'm looking at this, I'm going to say that this quadrilateral, A, B, C, D, is a rhombus because AB is congruent to BC, that is congruent to CD, that is congruent to AD. And that's all I know. Because I know that angle A is not congruent to angle B. And I know that angle C is not congruent to angle D. I know that information. Because those are not congruent means it is not a square or a rectangle. Okay, on theorem, we have three theorems for this section. Theorem 8.11 says a parallelogram is a rhombus if and only if the diagonals are perpendicular. This is an added property that happens for a rhombus. Okay, a rhombus, the diagonals are perpendicular. What's nice about that, being perpendicular, means now I have four right triangles in the center of a rhombus. To fill in my blanks, I mean my diagonals. I'm going to say AC is perpendicular to BD in that rhombus. On 8.12, it says, okay, the rhombus, there's another property of a rhombus, is that each of the diagonals bisect the opposite angles. Cuts them equal. So in this example that I have here, it's bisecting. Notice these have double angles. That means they're cut equal in side lengths. So AC is bisecting angle. Okay, let's start with the top one. I'm going to say BAD, as well as I'm going to say BCD, are the angles that are being bisected. And then the diagonal BD is bisecting ADC as well as CBA, and of course you could write those in opposite order. Theorem 8.13 says a parallelogram is a rectangle. Here's a property of rectangles if its diagonals are congruent. Okay, means they're equal in length. So if I'm looking at the example, notice I have one congruent marks, means all parts are congruent. That also means they bisect each other, by the way. It says that this parallelogram, or this quadrilateral ABCD, is a rectangle if AC is going to be congruent to BD. Now realize, since a square is both a rhombus and a rectangle, the square has all of these properties. So a square, the diagonals are perpendicular, the diagonals bisect the opposite angles, and the diagonals are congruent. So a square has all of these properties. Okay, going into our third example. Says you are building a frame for a painting. The measurements of the frame are shown. So here's my drawing of my frame. It's a 16 by 20 frame. The question is the frame must be a rectangle. Given the measurements in the diagram, can you assume that it is a rectangle? Remember, a rectangle, to justify that something is a rectangle, we must know that the diagonals, there it is, sorry. We must know that the diagonals are congruent to each other. That's what indicates that this has to be a rectangle. Other than the corollary on a rectangle, says that you must have 4 right angles. So 4 right angles, or the diagonals congruent to each other. If I'm looking at my picture, do I know anything about the angles? I mean, the only thing I see is that opposite sides are congruent in this setup, which is characteristics of a parallelogram. I don't know that they're parallel to each other, but if these two sides are the same length, then I can assume that these are actually parallel. Okay, let me put my little parallel symbols on there. But do I know that this is a right angle? That's the question. Because it could be tilted and not actually be a square. So can you assume it is a rectangle? I would say no. You don't know the diagonal lengths. You don't know the diagonal lengths are equal, or the angles. You don't know either one of those concepts, so no, you cannot say that. On B, they give us some additional information. It says you measure the diagonals of the frame. The diagonals are about 25.6 inches. Now, what can you conclude about the shape? Well, if my diagonals from one end to the other is about 25.6 each, then yes, now I can say the frame is a rectangle. I know it is now because on Theorem 813 it says the diagonals are congruent. Okay. Okay, I have 3 practice problems that I've squeezed on my page. If you'll pause, copy them down and work them, and then restart it, I'll go through and answer them and see if we match. Okay, on number 1 it says for any square CDEF it is always or sometimes true that CD is congruent to DE. So I have a square. And I have to think about a square. I know all sides are congruent and all angles are congruent or right angles. I know that information. And realize I have to wrap around my shape. So this is saying that CD is congruent to DE. It says for any square, it doesn't matter what size square I do. Is that always or sometimes true? Well, since this is a square, that must be an always true, and my explanation is that this is characteristics of a square, but it's also a rhombus. Okay, I'm going to say squares are rhombuses in this situation. Number 2, a quadrilateral has 4 congruent sides and 4 congruent angles. What must it be? Well, to be 4 congruent sides classifies it as a rhombus. 4 congruent angles means all the angles have to be 90 degrees. That would be a rectangle. For it to have both properties means this is a square. To have both, it means it's a square. Okay, looking at example 3, it says we want to classify the shape. Well, I notice, even though my picture looks kind of funny, all sides are congruent. Since all sides are congruent, I know it's either a square or a rhombus. Then I look at the angle Q, says it's 97, and since that's not a right angle, means this has to be a rhombus. Then they want us to find X and to find Y. But look at X. It's the side measurement, so that means I'm going to, let me put this on a separate piece of paper here. And let me put it on the bottom of this page so that I can see that AX will actually equal 5X plus 6. Well, I'm going to subtract 5X. That gives me 3X is equal to 6. Divide by 3, and X equals 2. Okay. Now, if I look at the angles for Y, notice it's in parentheses with a degree symbol. The properties of a rhombus are that the angles are supplementary. So that means I'm going to take 97 plus 12y minus 1 and set it equal to 180. Well, if I simplify this, that's 12y plus 96 is equal to 108. I want to subtract 96, and I'm not sure what that will be. I think it's 84. Double check. Yes, that is 84 is equal to 12y. I'm going to divide by 12. And that gives me 7 for my problem. Okay. If you got these correct, then give yourself a good old thumbs up. And if you don't like thumbs up, give yourself a good smile.